everyone. In today's lesson, we're going to talk about derivatives of exponential functions. So first, we're going to start with e to the x. So if I want to find the derivative, d dx, of e to the u, e to some power, the derivative is equal to e to the u, so the same thing as the original, then times du over dx. And du over dx means find the derivative of this u, or this power. So in simplest form, we can say the derivative of e to some power is the same times the derivative of the power. That's what that means in words. So let's use that. So the first example, y, is e to the x, and I want to find the derivative, dy over dx. So we know that it's the same, so e to the x, times the derivative of the power. Well, the derivative of x is just 1. So dy over dx in simplest form here is just e to the x. So a thing to note is that when I have a function y equals e to the x, the derivative will be the same thing. Y equals e to the x will be the same in the derivative as it is in the original. And that's always going to be the case in this simplest form. Now, we're going to get a little bit more complicated with the exponent, and then things won't always be the same. So let's do some more examples to see. So the next one, 3e to the x. If I want to find the derivative, dy over dx, this is the constant multiple rule, where we just keep the 3 in front and then takes the derivative of e to the x. And since in example number 1, we know that e to the x is the same times the derivative of the power, we could have just written e to the x if we wanted. Our dy over dx in simplest form here will be 3e to the x. So here is actually another example where the derivative is the same as the original. And this is the same because of that constant multiple rule, which says if I have a constant in front, I just take it down for the derivative. So let's see another example where this may not be the case. So example number 3, we've got y equals e to the 3x. So if I want to take the derivative, dy over dx, the derivative is the same times the derivative of the power. Well, the power here is 3x, so the derivative of 3x is just 3. So my final answer, if I simplify it, dy over dx is 3e to the 3x. It's just nicer to write the coefficient in front, and that's it. All right, let's try another example. How about example number 4? If I want to take the derivative, dy over dx, we know the rule for e is same times the derivative of the power. But here we should notice that my power is a product rule. I have x squared times cos x. So I need a high, which is my x squared, and a cos x, which is my low. So if I do the product rule, it's low times d high. D high, the derivative of my x squared, is 2x. So that's here, low d high, plus high d low, the derivative of cosine, well, sine, cos, negative sine, negative cos. So the derivative of cosine is negative sine. Now, you can leave your answer just like that. You don't necessarily have to simplify it, but that would be our derivative. All right, why don't you try example number 5 all on your own, and then hit resume when you're ready for the answer. Okay, so dy over dx, we keep the 4, and we multiply it by the derivative of e to the x squared. So e to the x squared, we take it, and it's the same, times the derivative of the power. And the derivative of x squared is 2x. This one we actually can simplify, so I'm going to make this one dy over dx equals 8x e to the x squared. And that would be my final answer. All right, let's move on to the back. Okay, so now we have examples of another exponential function. It just doesn't have e. It's a, where a is any constant, right? So notice how in these examples I have 8, I have 9, I have 3, I have 6, any number other than e to the x power. So the rule for the derivative here is similar, where the derivative of a to some power is the same times the derivative of the power times now the ln of the base. So let's write that in words. Same times the derivative of the power times ln of the base. Base being the bigger number. Notice the a is the bigger number. So same times the derivative of the power times ln of the base. So for example number 1, if I want to find the derivative, dy over dx, same times the derivative of the power. Well, the derivative of x is just 1, times ln of the base, the big number, 8. So again, if you want to simplify, dy over dx is 8 to the x, ln of 8. And that's it. That's your final answer. That's your derivative. Okay, why don't you guys try number 2 and then hit resume when you're ready for the answer. Okay, so derivative, dy over dx, is the same, 9 to the x, negative x, times the derivative of the power, which is negative 1, times ln of the base, which is 9. So if I wanted to make this as simple as possible, I could write it as dy over dx equals negative 9 to the negative x times ln of 9. Perfect. Okay, how about number 3? So number 3, we have y equals 3 to the sine x. So remember, dy over dx is same times the derivative of the power. So sine, cos, negative cos. The derivative of sine is cosine. So same times the derivative of the power times ln of the base, which is ln of 3. Now, this one you can't really simplify too much, so you can kind of just leave it like that. All right, why don't you try number 4 and then hit resume for the answer. Okay, so dy over dx is the same, so 6 cotangent of x, times the derivative of the power. So the power here is cotangent. You might need to look this one up. The derivative of cotangent is negative cosecant squared of x times ln of the base. Base being the bigger number here, which is 6. Okay, number 5. If I want to take the derivative of this, we're going to say dy over dx is the same, so 4 cos x sine x, times the derivative of the power. But if you notice, the power is a product rule. It's cosine of x times sine of x. So cosine is my high, sine is my low. So low times d high. So we may need sine, cos, negative cos. So the derivative of cos is negative sine. So we just did low, d high, plus high, which is cos x, times d low. So my low is sine. So if I look at sine, my derivative of sine is cosine. Then don't forget it's times ln of the base. Now normally I would say you don't need to simplify this one, but you absolutely can. So dy over dx can be simplified to 4 cos x sine x times negative sine squared x plus cosine squared x times ln of the base. And that's good enough there. All right, why don't you try number 6 and then hit resume when you're ready for the answer. So dy over dx is same times the derivative of the inside, which happens to be a product rule. So the x squared is my high, and the tangent x is my low. So low d high. The derivative of x squared is 2x, so low d high, plus high d low. The derivative of tangent, you might want to look that up, is secant squared of x. And then don't forget to multiply it by ln of the base, so ln of 5. And that's good enough for me. That's your final answer. All right, that's it for today. If you have any questions, now's the time to jot them down and ask us in class tomorrow. All right, have a good night.